Hello, greetings everyone. Uh, greetings everyone. Welcome to another live session from Affine. It's a very exciting time of the year. There are a lot of celebrations in the air, and Affine especially is celebrating something very special. So we have recently been recognized as a preferred service partner for an AWS software development kit called AWS Panorama. It's something that helps reduce the latency of some of the solutions, some of the computer vision solutions that we are using in most of the surveillance and monitoring parts of pretty much every industry. Now, to talk more, to give you a little more in-depth analysis on what the computer vision solutions are and how they impact the businesses. Today we have with us Ravi Teja, who is a senior principal and he's heading the manufacturing center of excellence at Affine. Hi, Ravi.
Ah, Hi, Alex. Thank you for inviting me again on this platform. I love to listen to the other panelists and see where this goes.
Absolutely. And we also have with us Mahesh, who is the director of the Cloud Center of Excellence. Hi, Mahesh. Welcome onto
Hey,
the
hi,
platform.
Alex. How are you?
Yeah, we are very super excited more about the applications and the business potentials and the impact of AWS Panorama and how us Affine being a preferred service partner for AWS Panorama, how it is going to impact our potential clients and all the team. So over to you, Ravi. Ravi, actually, would you be able to give us a bit of a gist on what computer vision solutions are and what are
Sure, sure. Let me do that. Let me do that. And to give you a little more context and why I'm doing this is as part of my job role, I talk to a lot of manufacturers, and quality happens to be one of the concern areas, right? And within quality, computer vision is one of the technologies which has the highest potential. So now to just break it down, right? What exactly is computer vision? So think of it this way, right? The act of human inspection, right? A simple seeing through our eyes and then using our brain to process it, and then our limbs taking actions, right? Let me give you a simple example to break this down further. So let's say if I'm going to a retail store, I pick an apple, right? My mind helps me differentiate between good to bad apple, right? And my hands do the act of picking or dropping a bad one, right? Now, if I bring this in context of a industrial use case or a quality use case or human inspection, right? Now, what you see here is a generic computer vision architecture. So the camera here does the role of our eyes. Now, camera could be a function of lights, lenses, camera modules, sensors, so on and so forth. And then they're connected to some kind of a compute device. Now, this compute device is in turn our brain, right? Which helps in detecting if there is a part present, if a part is missing, if there is a defect, if there is no defect, so on and so forth, right? And then it takes a call, or there is a inferencing which happens, right? Now, this image inferencing is a function of what kind of AI ML models are deployed on this compute device, right? And then also, even before the inferencing happens, there has to be certain kind of image processing which has to be conducted, right? Now, all of this together is what AWS Panorama also does. And my colleague Mahesh here will obviously talk about that. And then the inference which comes out of this edge device, right, is passed on to some kind of actuator, which could be a simple robotic arm like this, from KUKA or some other manufacturer. And that the robotic arm understands what to do with it, right? Whether to flip it, whether to throw the product or pick the product or do some action, right? So that kind of trigger happens here. Now, Mahesh here, my colleague and a good friend, right, who also happens to head our cloud team, would talk about what AWS Panorama does in context of computer vision, right? With that, let me invite Mahesh here and take you through next slides.
Right. Ravi, if you could just go on to the next slide.
Sure.
Yeah, great. So, as Ravi mentioned, we're talking about AWS Panorama today. It's an appliance, and it comes in form of an SDK as well for folks who actually develop the peripherals and cameras to test. So one of the points when Ravi mentioned about inferencing, so before even going there, a team or a company like ours would build those ML models. For building those ML models, you require a lot of computational power. So that's an activity which happens fewer times. But inferencing is an activity which happens far too many times, and rather regularly. So the cost involved in inferencing is high when it's done frequently. So the Panorama device as such does inferencing on the edge, and that hugely reduces the cost for the companies with respect to the inferencing part of it. Apart from it, even with respect to heat generation, since the device is small, it is localized, the heat generation also is quite less. The power utilization also is phenomenally less. So this will play a part over in the larger scheme of things. Ravi, if you could go to the next slide. So one of the key aspects which I would like to cover, in the sense more concentrating on Panorama being an edge device. One of the important factors is that in industry, inferencing, sub-second inferencing is very key. So Panorama does that for you. It's having very less latency, very highly accurate inferencing is something which yields. Apart from it, you have a single console through which you can manage all your day-to-day activities with respect to uploading a particular model. Bandwidth usage again features in as one of the higher issues with respect to the industrial use of computer vision. One of the key problems which we see is that industries are far too apart from places where in which they have high network. Apart from it, industries also have compliance issues because of which implementation of computer vision becomes a challenge. So Panorama does address those issues as well. Since the inferencing is happening on the edge, the information which is being gathered through the cameras stays inside the shop floor or the building premises of the industry. Apart from it, one of the other features which is groundbreaking is that you don't need to basically invest on upgrading your cameras. You basically use the same set of cameras which you had earlier. The only condition is that it needs to be having real-time streaming. It has to be compatible with RTPS. So the real-time streaming protocol, that's something which it needs to be part of. If you could go on to the next slide. If you actually take a look at the appliance, the size of the appliance is as small as a PlayStation console. The beauty part of it is that the set time for this particular device is extremely short. Again, as I mentioned to you earlier, the cameras are definitely a boon. Industries who have already invested on those cameras can basically reuse them. And of course, it is made rugged. It's an IP62 rated device. So it is rugged and it can be placed in several different places where earlier even keeping cameras would have been a problem. It's dust-proof and water-resistant for that way. It can take in multiple feeds, up to 10 camera streams are something which can be connected onto the device, and multiple models can run parallelly. Ravi, if you could go to the next slide. So overall, I would just give a small brief on how Panorama works, or how it could how we could implement it. So of course, depending upon the use case, the company, the industry would think about building the ML models. Of course, Affine being the preferred partner, preferred service partner, would always be play a pivotal role in building up these models. Of course, then there will be a single core interface through which you will be deploying those models, applying a business logic to basically address whenever that event would occur, and appropriately taking action. So that is something which the crux of Panorama would go through, the whole life cycle of Panorama would go through. So Introducing Panorama to an existing network inside an industry is pretty simple. The device as such has a network port, basically has two gigabit network ports. So you can basically connect it to multiple sublets. Once connected and activated online, it would it would basically scan for cameras internally and list it out. You would then attach those cameras and deploy your ML models. You can deploy multiple models to a single stream, parallelly run those as well. And just to give a short example, of course, Ravi will take you through all the use cases once this is done. But just to name a short use case, I would say when you look at shop floors, you would look at people's safety to be paramount. So there would be certain areas which you would have people mandatorily to use safety equipment like hard boots and hard hats. So a ML model could basically identify, basically using the stream from the CCTV cameras, could identify certain areas, cordon of certain areas, and whenever a person walks through there, it would basically identify a person first of all, and after that, check whether the person is wearing the safety equipment, like boots as well as the hard hats. If in case it detects a person without the helmet or the hard hat, it would basically trigger an event, and probably you could trigger that to the localized system to basically have a siren or inform the safety officer on the shop floor to basically address the particular problem. So this is one of the use cases, and the implementation is very, very simple. Of course, one of the main cost savers, it being an edge inferencing device, the cost of inferencing is next to zero. It would take in some amount of money to take in a very what do you call minuscule amount of money to basically attach the streams. Once attached, it would not incur any cost. So that becomes a huge factor for larger industries. Of course, you can pile on multiple Panorama devices and attach more streams onto it. So that would be a rough idea of how Panorama works and how we could get it implemented on an industry. Yeah. So I would like to end the first part of the LinkedIn Live with respect to Panorama. Again, I just want to reiterate the fact that Affine is a advanced consulting partner with AWS. We are also taking up the ISV route now with the assetization team internally. Then, of course, recently we've been we have become the preferred service partner with AWS Panorama. We were one of the few who actually started working on the preview for both Panorama as well as LFV, Lookout for Vision. So yeah, and we are continuously working with the Panorama to build up new use cases and help our customers develop enterprise level solutions using AI and ML on the cloud. Yep. Ravi, over to you for the use cases.
Thank you, Mahesh, for the wonderful details on the Panorama device and the appliance, right? And how, let me give you some kind of glimpse of how this device in action can be used in different industries, right? And you can definitely look us up, and even Mahesh on LinkedIn if you want more information on AWS Panorama. And you can also come to our website, affine.ai, right? Now, the first use case, what you see on the extreme left and where my pointer is at, right? So this is for a FemCare division of a leading CPG organization. Now the product in contention is a sanitary pad, right? Now, like any consumer product, these products are developed on a line. Now on these lines move at a certain speed. There are multiple lines, and then the products are manufactured and then they're packaged, right? Now, the sanitary pad as a product is nothing but a combination of different layers of fabrics coming together. Now, when these different layers of fabrics come together, right, there could be different challenges in terms of defects. Now there could be a simple defect in terms of misalignment of different fabric when placed over each other in terms of alignment, and then that could cause some kind of a fold, some kind of a wear and tear. While embossing the brand logo, there could be a misplacement of the logo, there could be challenges with respect to the ink being sprayed on the product, right? And there could be normal wear and tear of the product as well. Now the idea was this, when we were talking to the client for the first time, that let's do it on one of the lines, right? Understand first how fast does the line move. Now given Panorama has properties which can do detection and inferencing within a second, right? This would be, or this is of a great help in scenarios like this where the lines move very fast, right? We're talking about multiple hundreds of product coming out of line per minute, right? So idea is first detect whether the product which is coming out of the line is defective or not defective. Now this is just to eliminate defects, but if we want to understand what parameters are creating these defects, we need to understand the properties of these defects as well. Now, so this is where computer vision and Panorama helps us take this one step further. That is, identifying the type of defects, help us localize the defects, and also grade defects into different categories, right? And that helps the quality team in assessing and changing the input parameters to the machine, and that completes and closes the loop of automating the inspection as a whole, right? Now this not only automates the inspection and frees the QC inspectors and help them take better and bigger roles, but also removes defects, right? And causes less pain for the customer, right? Lesser recalls, right? And your production rate also can be increased because the Panorama kind of a device, right, or can help you detect these defects at a really fast rate, and hence your line speed also can be increased, right? So this is one of the use cases within a CPG manufacturing setup. The second one is in one of the heavy industries. Now we were in a conversation with a client who happens to be a steel industry major, and they develop these flat products. Now these flat products, as you see in the image, are rolled onto a coil, right? But before they're rolled onto coil, we need to ensure that what is there a defect or not, right? Because eventually these coils would be used by, let's say, auto player to make different auto body parts, and as a customer, eventually end customer wouldn't like if there are any kind of defects, dents, shear, tear, or any kind of a corrosion on any of this, right? So idea is this: one, you place cameras on both sides while this coiling is happening, and you detect defects, right? And the inspector or the QC person on the line, what they do, as soon as the defect is detected, they cut that piece out, and then the rolling continues. That way you remove the pieces which have some kind of defects on it, and they're not passed on to the customer. This is one of the use cases. Second, in the same for the same steel cold rolling mill, right? What also happens is the width of this product, right, now you see should be very consistent. Now because of this rolling, there could be some challenges in terms of the changes on the width. Now to again computer vision or machine vision solution could be also used to check if the width of the product is right, and we could set different tolerance limits, and we could again give a alert to the inspectors out there that at this length the width is higher, this length width is lower. So again you can remove that part of the product, right? Now this line or this sheet moves at a rate of close to around 100 to 120 meters per minute, right? This is a significantly high speeds. Now the machines have potential to move up to 200 to 250 meters per minute. Now what a computer vision solution helps us do is detect defects faster at a better rate with a much higher accuracy, and you can increase your production rate or the line rate from 100 120 meters, which is limitations of a human inspector, to much higher. It could be 150 to 200 meters per minute. And that can give you immediate boost in terms of production, right? And hence gives you much better throughput. So that's one of the use cases. Let me talk about one more in automotive space, right? Now, as you would all know, automotive products are very complicated, and there are close to around 8,000 simple or complex auto ancillary products which come together and form a automotive vehicle, right? Now, when there are different products coming together, they could be fastened using nuts and bolts, welding, and different other way of fastening. There could be always chances of missing products in first place, right? And that's a simple technique called Pogayoki by a Japanese way of identifying and ensuring that we don't mess products out, right? So just to check if the product is rightly placed on my parent, a child product is rightly placed on a parent product, right? That could be one of the use cases for within automotive. Now, the use case what we have in contention over here is this, right? What you see here is a small ceramic part. It's a microscopic ceramic part. It only runs into few mm. Now, this ceramic part goes and sits in a bigger parent part, and then that parent part goes and sits in a vehicle. Now, the cost of this is not very high, right? This runs into few cents. But if there are defects in this, and this happens to go and sit in a bigger parent part, and that happens to go and sit in a bigger vehicle, there could be chances when a final product is rolled out and you miss out the defects from here, there could be a recall from the customer. And all of you might know that recalls are very expensive in automotive industry, right? So to avoid that, what we did was we developed automation fashion for this QMS process. There was a robotic arm placed which could flip the product in different angles, so that we could capture the images from all the angles, not only the outside surfaces, but also from the inside surfaces, right? And then we had a camera placed with a certain lighting, which is suitable for a ceramic kind of a product or a material. And we could identify the defects very well, right? And then the robotic arm was given a alert based on the edge module that there is a defect and please throw this product out. And that not only helped us give much better throughput, but the amount of defective products going out of the line improved significantly and helped reducing the recalls of the automotive vehicle finally, right? So let me cover one more use case in automotive. This was one of the leading auto player, and what they do as part of R&D is test their vehicle bodies in extreme weather scenarios and see how long do they last. And they kind of accelerate the process by dipping the automotive body in a salt solution or exposing to different accelerated weather conditions and see how does my car age, right? And within a few days, a car is made to age worth of a few years, right? Now, after this process is done, there is a corrosion team which comes in and sees how my different body parts are getting corroded. Now, the challenge with a corrosion team is this, right? This skill, to learn this skill, it takes a lot of time. It takes a couple of years to learn really well how to identify corrosion. This is a simpler image though, but the actual product were more complicated than this. There are different types of corrosion. There are different grades of corrosion which the quality inspector has to grade it in. And that's not very easy to do. And it takes a significantly long duration to inspect the complete body of the car from all the angles. And this used to run into a couple of hours to a day, right? The complete process of inspecting. Now, with a computer vision product, and it was integrated through a web application, this complete process was brought down to few minutes, and that saved a lot of time. And it's also not easy to get new skilled workers in this space, right? As things are getting automated in very accelerated fashion, right? So getting skilled workers to identify corrosion and to be trained in such an in such situations is also not very easy. So it helps you come out of that situation, right? Now, what I have here, the second use case in this slide is around retail, right? Now, when a customer walks into a retail store, they interact with the products, right? Now, you pick up the product, you read the label, you read the branding, you see the branding. Now, there could be different kind of scenarios playing out, right? Now, there's a there's a high chance that customer picks up all the products which are on a high level, right? And high chance that you might miss the products which are on lower shelves, on higher shelves, right? Now, for a retailer and even for a brand to understand what is customer doing, how is he interacting with different products, could be of huge value to them, right? In terms of understanding how to make the layout of the store, how to place what kind of product in what kind of shelf, in what at what kind of distance, right? And eventually, when all of this intelligence is used well and the layout of the store is created accordingly, this would definitely help them in increasing the sales and definitely improve the shopping experience of the customer as well, right? Now, this is the last use case. I'm trying to give you a glimpse of all the different industries. Now, this is again what Mahesh spoke of, right? Safety is one of the biggest concerns, right, in a industrial setup. Now it's mandatory to wear a PPE, personal protective equipment, right, in a manufacturing setup, which includes gloves, safety vests, goggles, and even hard hats, right? And let's say if you are going into a zone which has a overhead crane, right, it is mandatory for the person to have a hard hat because there could be chances of incidents. Now, a computer vision system helps you detect that when a worker is moving into such hazardous places. Now, are they wearing the right set of protective equipment or not? Now, this could be extended to many other applications. Like in a COVID scenario, we could also look at how socially people are gathering, right? Are they wearing masks? Are they washing hands, right? Are they maintaining social distance, so on and so forth? And this all helps you being compliant and reduce incidents in a shop floor kind of a scenario, right? Now, these are some few quick glimpses on how this can be used, right? Now, if any one of you wants to know more on these use cases on how do we use computer vision in your particular context of business, right? Please reach out to us on a Affine website or look us up on LinkedIn and drop us a note. We would love to take you through much in detail, right? How the hardware, software, and the integration of all of it comes together, right? With that, I'm at the end of the presentation, and I would like to thank Alex and Mahesh to run this well, right? And if there are any questions, we would love to take that. What is the AI model used for defect detection use case? I can see classification model GradCam was presented. Wouldn't it be better to use an object detection model? So again, what kind of model is completely a function of what use case are we trying to solve, right? Now, depending on the use case, right? If you're trying to identify what kind of a defect it is, right, or what kind of object it is, then a different kind of a model could be used. If you're trying to measure the length or a width of a certain object, a different kind of a model could be used, right? Or there are multiple simpler techniques also, like pixel counting and things like that, right? So it's a complete function of what use case are we trying to solve it. And at Affine, the way it goes is we try out different models for every problem statement, right? And ensure whatever and whichever model gives us the best result, that is what goes into the client solution, right? So that's how I would answer that. I think we are towards the end of the session, and I would like to thank everyone to attend this, and have a good day, guys.